We have Shaquann telling us about revealing the magnetic South Pole, strongly magnetic O-star NGC 1624-2.
Hello, everyone. My name is Shaquann. I'm a PhD candidate at the University of Delaware, and today my talk will be about the strongly magnetic O-star NGC 1624-2. And so, when I say strongly magnetic, I mean strongly magnetic. So at 20 kilogauss, this is an order of magnitude stronger than any magnetic O-star we've ever found. So that makes the star a candidate worth studying. And so what I'm talking about today with Unveiling the South Pole is a project that came out of a project that came out of a project. So basically a thesis that wrote itself. So starting off, so it began with corrected rotation period. So looking at magnetospheric emission, so what I have plotted are equivalent lists with the maximum emission at the top of the plot. When we study the variation in magnetospheric emission, we can constrain the rotation period, and looking essentially at the peaks of emission, those coincide with what we plot at the bottom, which is a curve for mean longitudinal field measurements. So a peak in emission coincides with an extrema and mean longitudinal magnetic field. So 158 days, wrong. 153, a significant improvement, much more coherent. And what we see is that at the peak emission, from the magnetosphere, we have an extrema in in mean longitudinal field, and it's all one polarity. But we got curious and said, okay, let's revisit twice the period. So what we would expect is that there should be two peaks in emission, but also two extrema, but opposite polarity. And this is where the new project came out. So looking at the double wave, or twice the period, there is an entire cumulative gap of measurements that we just don't have for the past 10 years for what we would expect to be the negative polarity of -2. And so the significance of this is that, so when I say peak emission and therefore extreme and mean longitudinal magnetic field, this has a geometric interpretation. So the first is where we only see one pole. The latter, we expect to see two. So we see both north and south. So we have an entire region of the southern magnetic hemisphere that we are not observed, that we have not had measurements for. And so with the new CFHT observation, we were able to get observation this January, actually. So what you see here in red is an earlier observation for three spectral lens. So we have the Stokes V plotted above. So red and pink are early, and blue and cyan are fairly recent. And you see basically strong Stokes signature, but inverted in form. So that is evidence that we have basically a polarity inversion, not in the sense of like solar, but we found a southern magnetic hemisphere measurement. And so with our first trial measurement, which I show here, yes, we confirm that there is an entire magnetic hemisphere for the star that has just been unobserved. And that concludes my talk.
Question. This is what I like to think. Thank you, Adam. Thank you very much for providing this presentation. Like, for my experience, that we said it all for years, right? Really like it. 15 observations for your up would be relaxed. Yes. So, this is kind of bipolar with the film because I can see those fires, and I see that the research how it was about sound where to part goes. So your precision is like 10 times like 0.5 grams. So because I cannot see all precision, like error was quite comparable to the side.
Oh, forgive me. Yes. So yes. So this is So the units are kilogauss, but yeah, the error bars are roughly on the order of like 10 to 100 gauss per measurement.
Yeah. So